Hey everybody, this is Dr. Jacobs, and I wanted to show you a little bit how to use SPSS to analyze your data set. So if you can see here for the example, we are looking at the number of alcoholic servings or alcohol drinks that people had before they were in dry January and then also after. So when you have your data set, you would put a label up at the top here like we have for before. It has to be just one word. There can be no spaces. So if you have more than one word, you just need to put it so that there's no spaces in between them. So we have this data view. We see here 1 represents our first participant. So this one participant had 8 drinks before doing dry January, and after had 2 drinks a week. And so when we go here, we'll also want to go to variable view. This is where you can change the name of each of the variables. But also what you need to do is change the level of measurement like we learned about. So if we look here under measure where it says nominal, the number of alcoholic drinks you had is actually on ratio, because if you've had 0 alcoholic servings, that means you haven't had any drinks. So we'll change both of these to scale because both of them actually are showing the number of alcoholic drinks. So you go here, we have it on scale because they're both on a ratio level of measurement. There's some things that you need to do that you may or may not have learned in your prereq stats class, and that deals with something called parametric assumptions. So anytime that we're running a statistical analysis, there's some things that we have to check to make sure that we can run some of the analyses that we learn. So with the dependent samples t-test, which we're using here, which is where we have the same participants in each of our conditions, we have to check something called difference scores. A difference score for a participant is one score. So in this case, the number of alcohol drinks they had before dry January in 1 week minus the number of drinks they had after. So in order to do that, we have to go up and add the difference score variable. So we'll go up to transform, compute. We're going to name this target variable difference score. And then we're going to put in that we want the number of drinks they had in a week before dry January. Then we're going to subtract the number of drinks they had after dry January. So double click that so that goes in there. Then we're going to click OK. What we're going to find here is that it has our different scores all listed here in this third column. We'll want to go to that variable view again. We'll go over where measurement or different scores are still scale, because if there's no difference between the number of drinks per week they had before dry January and after, that means they had no difference or 0. So here are some of the parametric assumptions with the dependent samples t-test. The first one is that our dependent variable is measured on a scale. In this case, our dependent variable is the number of alcohol servings they've had per week, and that falls on a ratio level of measurement. We know that a scale is anything that falls on an interval or ratio level of measurement, so we meet that assumption. So we can check for the next one. Another one that we have is that we have independence between our different participants, and here we're assuming that nobody are drinking buddies, nobody lives together. That would influence drinking habits and things. Nobody's buying other people drinks in the sample. We're assuming that they're independent. Another thing to be able to do a dependent samples t-test is that our difference scores are free of outliers. The way that we learn to check this in my statistics course, there's many different ways that you could do this, is to calculate something called z-scores for each individual score. With the dependent samples t-test, we're looking at outliers for the difference scores. So in order to do that, you can just go up to Analyze. You can go to Descriptive Statistics, click Descriptives. We're going to move difference score as our variable that we're interested. And here it says Save Standardized Values as Variables. This will give us our z-scores. All right. So when we look back into our data view, we find here that our different z-scores. For something to be considered a z-score, it needs to be negative 3.29 or smaller, or positive 3.29 or higher. When we go through here, we can actually sort these if we want to sort ascending or descending, and that's going to give us kind of a funny looking thing here, because for some reason some of these are highlighted. Let me delete the empty cells here. We see that none of them are smaller than negative 3.29. None of them are 3.29 or greater. So we meet that assumption. Another assumption that we have is something where we say that our different scores are normally distributed. One way that we could check that is we could take these different scores and put them into a histogram and examine to see if we think that it's normal. Or a more sophisticated way that we could do that is to do some sort of analysis called the Shapiro-Wilk test for normality. I know that different teachers teach this in separate ways, so I'm not going to hold you accountable for having to do that, but I want to show you how you would do this if you're doing it on your own. So you go to Analyze, Descriptive Statistics, then you move over to Explore. So we're going to move our different scores over into this dependent list. This would be different if we were doing an independent samples t-test, but since we're doing a dependent samples t-test, we're just worrying about our different scores here. You go and click plots. Remember, I told you all you could do a histogram if you wanted, but the thing that we're going to be more interested in is this normality plot with tests, okay? Because this is going to give us a little bit more of a better idea than just looking at a histogram. So you're going to click continue, you're going to click OK. We're going to have some SPSS output that comes out. And what we're going to look for here is test for normality. Specifically, we're going to look at this one where it says Shapiro-Wilk, because that's the Shapiro-Wilk test for normality. And then we're going to look at this thing here called SIGS. This is what you probably remember being referred to as a p-value. For us to meet this assumption so that we can run our dependent samples t-test, this number here needs to be 0.05 or larger. We see that it's 0.559. It is larger than it's 0.05 or larger. So that means we can continue on checking our assumptions to make sure that we can analyze this data set using a dependent samples t-test. Our last assumption for the dependent samples t-test is that we randomly selected our sample from the population we're interested in studying. We did not do that. We actually used a convenient sample, so we violate that assumption, but that is okay. Our dependent samples t-test is robust to the violation of this assumption, which just means we can run this analysis anyway, as long as we don't try to generalize our results from our sample back to the population we're interested in studying. So that means when we get our results, all we can do is talk about our sample that we have. So now that we've checked all of our assumptions, we can actually go ahead and analyze our data set. So we'll go up to Analyze. With a dependent samples t-test, we're comparing means. So we'll go to compare means and proportions. Unfortunately, if you had stats with me, you know that they name statistical analyses a whole bunch of different things. The dependent samples t-test is also sometimes called a paired samples t-test. So that's the one that we want to click for this. Here we'll put our variable 1, which is our before, the number of drinks before dry January per week. And then we'll also have our after variable here, and then we're going to click OK. So when we get down here, we are going to find our paired samples t-test, our test statistic value, which is the value that you would have calculated in your statistics course, is 5.192. Our degrees of freedom are 10. And here the significance level, because we are doing dry January, we probably would have hypothesized in our research hypothesis that people drank significantly more alcohol before dry January than after. So we would go here, that is a one-sided, that's a one-tailed test. So we'd look under one-sided. Here we see that it's less than 0.001, which means we have statistically significant results. That means that we would go in and we would have to calculate our effect size, which we have here. We see our Cohen's d, which is one of the ones that we use. We also see that we have confidence intervals. And then we would use this information to write our results because we have statistically significant results.